Good day, class. This is Sir Kenny, and today we will discuss module number 3 of STM006 or General Chemistry 2. Now, module number 3 talks about describing and differentiating the types of intermolecular forces of attraction. Before we begin, let us have our lesson objectives. So by the end of this lesson, you can say that yes, I can explain the different types of intermolecular forces, and yes, I can predict intermolecular forces possible for a molecule. Let us first differentiate intramolecular from intermolecular. Now, when we speak of intramolecular forces, these are the forces that hold atoms together within a molecule, which could either be an ionic bond or a covalent bond, with intra meaning on the inside or within. When we speak of intermolecular forces, these are the forces that exist between molecules, with inter meaning between or among. So, subukan natin pag-aralan yung picture na nandito dito. Now, we have three molecules of water. Water is composed of oxygen and two hydrogen. Now, yung bond between hydrogen and oxygen dito sa isang circle dito, yung kanilang bond is intramolecular because the bond holds the different elements together. Now, we have already discussed before that elements, kapag hindi pa kompleto ang kanilang valence electron, which is supposed to be 8 with the exception of helium, they will bond with other elements to form compounds para maging stable ang kanilang electronic configuration, para maging 8 ang kanilang valence electron. Now, they do this in order for them to become grounded or to become more stable. Si hydrogen, isa ang kanyang valence electron. Si oxygen, 6 ang valence electron niya. They need 8. So, ibig sabihin, ang mangyayari niyan, the hydrogen and the oxygen atoms will bond together in order to complete that 8 valence electron. So, that is what happened in this one, and also in this one. Now, the bond is called covalent bonding. Bakit? Kasi parehong non-metal ang oxygen at hydrogen. And that is within intramolecular forces. Ano naman yung intermolecular? So kapag sinabi nating intermolecular, this is the bond formed between molecules. And that these bonds are not permanent. They are temporary, which can be easily broken down. Mapapansin nyo dito na merong mga symbol ng delta, small letter na delta with a charge of positive or negative. Yung symbol na delta, yung small letter na delta, ibig sabihin niyan ay partial. So, it could have a partial positive or a partial negative charge. Pag-aaralan natin uli kung paano nagkaroon ng partial positive or partial negative. Although we have already discussed this when we tackled covalent bonding last semester. So, punta muna tayo sa intramolecular forces of attraction. Now, there are three types of bond that can occur between atoms kapag sila ay hindi pa stable. It could be an ionic, sometimes referred to as electrovalent. Electro, ibig sabihin may charge. Valent kasi yung valence electron. The other one is covalent bond. Co meaning share. Valent meaning valence electron. So, mag-share ng valence electron. And then we have the metallic bond. Metallic, coming from the word itself, ito yung bond between metals. So, isa-isahin uli natin for review. When we say ionic bond, this is the bond formed between a metal and a non-metal atom. For example, sodium and chlorine. Another notable characteristic of ionic bond is that nagkakaroon tayo ng transfer of electron. Dahil may transfer of electron, may mababawasan, may madadagdagan ng electron, and remember that electrons are negatively charged, magkakaroon tayo ng charges dito sa ionic bond. Yung mababawasan ng electron, siya yung magiging positive. Yung madadagdagan ng electron, siya yung magiging negative. Now let's go to covalent bond. So, covalent bond occurs between two non-metal atoms. So, kapag nagsama ang dalawang non-metal, covalent bond ang maform. It could either be a polar covalent bond or non-polar covalent bond. Paano natin malalaman? We have already discussed this. Titignan natin yung kanilang difference in electronegativity. Kapag ang difference or kapag pinag-minus mo yung electronegativity nila, At ang difference ay 0.4 pababa, 0.3, 0.2, 0.1, or 0, those are non-polar covalent bonds. Kapag ang difference naman sa electronegativity ay higit pa sa 0.4, so that means 0.5 pataas, those are polar covalent bond. Mamaya, we will discuss the differences ng polar and non-polar covalent bond in detail. Next, we have metallic bonding. This is a bond formed between two metals. Tapos yung electrons ng bawat isa will be shared by all, which will be called the sea of electrons. So dahil yung electron ay free-floating sa ibabaw ng mga metal na to, ito yung dahilan kung bakit metals are able to conduct electricity and that they easily transfer heat and electricity. So these are the differences at an atomic level. So when we say ionic, it is composed of a metal and a non-metal. Dahil si sodium ay isa ang kanyang valence electron, si chlorine ay 7, this is a metal, non-metal, so magkakaroon ng transfer. Yung isa ni sodium mapupunta kay chlorine. So si sodium nabawasan ng isang negative kaya magiging positive 1 si sodium. Si chlorine nadagdagan ng isang negative kaya magiging negative 1 si chlorine. So nagkaroon ng ions. Kaya tinawag na ionic bond. When we say covalent, nag-share sila ng electron. This happens between elements which are both non-metal, kagaya ni hydrogen. So pareho sila na non-metal, so they will share. Next, we have metallic. Yung sea of electrons, free-floating siya. So that means it is the one responsible kung bakit mataas ang conductivity ng heat and electricity between metals. Now let's go to intermolecular forces. There are 4 types of intermolecular forces of attraction. We have dipole-dipole, ion dipole, hydrogen bond, and London dispersion force. We are going to discuss the details of each type of intermolecular force. First, we have the dipole-dipole. So dipole-dipole interactions occur when the partial charges formed within one molecule are attracted to an opposite partial charge in a nearby molecule. So polar molecules align so that the positive end of one molecule interacts with the negative end of another molecule. Medyo mahirap siyang intindihin kasi hindi pa natin nadidiscuss kung paano nagkakaroon ng partial charges ang mga elements. So how do particles or molecules get partial charges? Let us have hydrogen and chlorine as an example. They are both non-metal, so that means magkakaroon sila ng covalent bonding. I want all of you to remember that dipole-dipole interaction is only possible between polar covalent bonds. Let us have this as an example of a polar covalent bond. Paano natin siya nalaman na isa siyang covalent bond? Hydrogen is a non-metal. Chlorine is also a non-metal, so covalent. Paano natin malalaman na polar? Remember the electronegativity values of each of the elements, which is indicated in the periodic table of elements. Si hydrogen, ang kanyang electronegativity value is 2.1, chlorine is 3. So kapag minus natin yung 3 at sa 2.1, 0.9 ang difference nila. Kapag 0.4 pababa, non-polar. Kapag 0.5 pataas, polar. Alam natin na polar covalent bond ang hydrogen chloride or hydrochloric acid. Ano ngayon kung polar covalent? So, isipin natin na ito yung sa gitna, ito yung equal distance between hydrogen and chlorine. Yun nga lang, yung electron ni hydrogen ay mas mapapalapit kay chlorine kasi mas mataas ang electronegativity ni chlorine kaysa kay hydrogen. Remember, 3 ang kay chlorine, 2.1 kay hydrogen. Mas malakas ang hatak ni chlorine kaya mas malapit sa kanya yung electron na shinare nila ni hydrogen. Remember that electrons are negatively charged. So therefore, since mas mataas ang electronegativity ni chlorine, mas malapit ang electron na shinare, therefore chlorine will have a partial negative charge kasi electrons are negative. Dahil mas malayo ang electron kay hydrogen at ang hydrogen ang matitira dito ay yung nucleus niya which is composed of the proton. Protons are positive. So therefore, since mas malayo yung electron kaysa kay hydrogen, hydrogen now will have a partial positive. Bakit hindi pwedeng positive lang? Bakit hindi pwedeng negative lang? Bakit kailangan na partial? Remember, hindi siya ionic bond na kailangan positive or negative. When we say covalent bonding at sinabi nating polar covalent bonding, partial lang ang pwede magkaroon na charges between the elements. And because of that, chlorine will have a partial negative charge and hydrogen will have a partial positive charge, as illustrated by this picture. Now let's go back. So kapag sinabi nating dipole-dipole interaction, nangyayari lang siya sa mga molecules na may partial charges, partial positive at partial negative. So, ano ang mangyayari kapag nagkalapit, for example, ang mga hydrochloric acid molecules? So for example, this is one hydrochloric acid and this is another hydrochloric acid. So si chlorine ay may partial negative, illustrated by this. Si chlorine ay may partial negative charge. Samantalang si hydrogen ay may partial positive charge. This is one molecule, this is another molecule. So dahil dito ay negative, dito ay positive, magkakaroon ng slight interaction between these two molecules of hydrochloric acid. Now, this is an example of a dipole-dipole interaction. Dipole, ibig sabihin, dalawang charge. Di means two, pole means charge. So, this is a dipole. Meron siyang slightly positive or partial negative. So, this is a dipole. And this has a partial positive and partial negative. So, this is another dipole. So, this is an example of a dipole-dipole interaction. Okay, now let's go to the other intermolecular forces of attraction. Now we go to ion dipole forces. So when we say ion dipole forces, these are similar to dipole-dipole interactions but involve ions instead of only polar molecules. So ion dipole forces are stronger than dipole-dipole interactions because the charge of any ion is much greater than the charge of a dipole moment. Ion dipole bonding is stronger than hydrogen bonding. So pag sinabi nating ion dipole, it involves an ion. It could either be a positive ion or a negative ion. Let us have the dissolving of sodium chloride or salt in water as an example. So because salt is composed of sodium and chlorine and when it interacts with water molecules, naghihiwala yung sodium tapos chlorine. So, nagkakaroon ka ng sodium ion at chlorine ion. So, for example, dito sa sodium ion, what will happen kapag naging sodium ion na siya ngayon at nasa water siya? Remember that these particles are water particles or water molecules. Yung mga maliliit na red, those are hydrogen. Yung blue, those are oxygen. Remember that water molecules have partial charges. Kasi yung hydrogen, 2.1, yung oxygen ay 3.5. Yun yung electronegativity nila. The difference in the electronegativity of oxygen and hydrogen is much greater than 0.4. So, ibig sabihin, polar siya. Magkakaroon siya ng partial charges, with the hydrogen being partially positive and the oxygen having partial negative. So, si sodium ay positive. So, aling part ng water molecule ang didikit kay sodium? Siyempre, yung partial negative. Kasi si sodium ay positive, di ba? So, ang didikit sa kanya ay yung partial negative, which is the oxygen part. Kaya makikita nyo na yung water molecules ay babaliktad na kung saan it will become attracted to the sodium ion. So, dito yan. For example, cation dipole, yung positive na ion. So, ang mangyayari dyan ay, since this is positive, ang ma-attract niya ay yung mga partial negative na part. Kaya, mapapansin ninyo, ito yung mga partial negative. This cation is surrounded by partial negative particles. Paano kapag anion or negatively charged? Kagaya nito. Ang harap sa kanya ay yung mga partial positive na part ng mga particles or mga molecules. So that is ion dipole forces or interaction. Next, we go to hydrogen bond. So when we say hydrogen bond, this is the attractive force between hydrogen attached to an electronegative atom of one molecule and an electronegative atom of a different molecule. Usually, the electronegative atom is oxygen, nitrogen, or fluorine. So technically, kapag si hydrogen ay naka-attach kay oxygen or kay nitrogen or kay fluorine, then the molecules of these substances will have a hydrogen bond. It could also either be nitrogen instead of oxygen dito. Pwede siyang maging nitrogen and it will still have hydrogen bond. It could also be fluorine and it will have hydrogen bond. What is important to remember here is basta kapag ang hydrogen ay naka-attach sa oxygen or sa nitrogen or sa fluorine, automatically, the bond that will exist between the particles of these substances is hydrogen bond. Now let us go to London Dispersion Force or LDF. So this is a temporary attractive force that results when the electrons in two adjacent atoms occupy positions that make the atoms form temporary dipoles. This force is sometimes called an induced dipole attraction. London forces are the attractive forces that causes nonpolar substances to condense to liquids and to freeze into solids when the temperature is lowered sufficiently. So London dispersion force is the only force possible for substances involved na kung saan they are nonpolar. Ibig sabihin, ang kanilang difference in electronegativity is 0.4 pababa. Pangalawa, they are composed of organic substances or CH bonds, carbon-hydrogen bonds. And third, if it involves noble gases. Remember, noble gases do not interact with other elements to form compounds under ordinary means. Nangyayari lang na nagkakaroon ng bonds between a noble gas and another element sa laboratory. It is only in under controlled environments. But in nature, never na nagkakaroon ng bonds with another element ang mga noble gases. So yun yung tatlo. Kapag meron yung tatlong yun, ibig sabihin then the bond formed will be London dispersion force. Bakit nga ba? For example dito, we have helium atoms dito. Helium is composed of two protons and two electrons. Now helium is a noble gas. Ibig sabihin, stable na siya on its own. Now there are instances na kung saan yung electrons ng helium ay mapupunta lang sa isang side. Kagaya nito, kapag yung itong electrons na to ay napunta sa iisang side lang, napunta dito sa part na to, then that means magkakaroon siya ng temporary dipole. Temporary kasi mabilisan lang yon. Now, kapag merong dalawang helium atom at yung isa ay biglaan lang na nagkaroon ng dipole kasi napunta yung dalawa niyang electron sa right side, napunta yung dalawa niyang electron sa right side, for example, then remember electrons are negative. So, na-focus lahat ng electron dito sa right side na to, so magkakaroon ng partial negative dito. Dito, walang electron, so magkakaroon ng partial positive. Okay? So, since nagkaroon siya ng partial charges, na kung saan ito ay temporary lang, tinatawag din itong instantaneous or biglaan lang na dipole. Kapag meron siyang katabi or adjacent na helium atom din, since dito, naging isa siyang instantaneous dipole, yung isa naman magiging induced dipole kasi naapektuhan lang siya. Nagkataon lang na nagkaroon ng partial charge dito sa right side na helium atom, so nangyari naging induced dipole siya. Naapektuhan lang siya ng pagiging dipole. Pero panandalian lang yan. Remember that among all the different types of intermolecular forces, London dispersion force is the weakest of them all kasi panandalian lang talaga siya. Yung nagkataon lang na dipole, we call that instantaneous dipole, biglaan, mabilisan. Yung naapektuhan, ang tawag sa kanya ay induced dipole. So that is London dispersion force, which is only possible in substances that involves organic substances, nonpolar substances, and noble gases. So this is a graph that I made para intindihan natin kung paano dapat i-classify ang mga substances. Depende sa kung anong type of intermolecular force meron sa kanila. Number one, aluminum and argon gas. So, pinagsama daw ang aluminum at argon gas. So, mag-start tayo. Do the substances involve organic compounds or non-polar covalent bonds or noble gases? Argon is a noble gas. So, yes, automatically, this is an example of a London dispersion force because of the presence of argon gas. Paano naman kapag calcium sulfide in water? So, start. Do the substances involve organic compounds? Meron bang CH compound dito? Wala. May non-polar ba dito? Calcium and sulfur, metal, non-metal. This is ionic. Hydrogen and oxygen, the difference in electronegativity of hydrogen and oxygen is greater than 0.4. So, this is polar covalent. So, hindi applicable ito. May noble gas ba dito? Wala. So, punta tayo sa no. Next, do the substances involve metals or ionic compounds? Dito, sa calcium sulfide, this is an ionic compound because calcium is a metal and sulfur is a non-metal. Pag nag-combine sila, magkakaroon ng transfer of electrons. So, this is ionic. So, number two, yes. So, therefore, this is an ion-dipole interaction. Third one, chlorine gas and krypton gas. So, do the substances involve organic compounds? Meron ba dito? Wala. Non-polar covalent bonds. Chlorine, dalawang chlorine. So, ibig sabihin, 3.5 na electronegativity minus 3.5, that's 0. So, non-polar siya. So, kasama na siya dito sa non-polar, meron pa tayong noble gas na krypton. So, yes. So, number 3 is London dispersion force. So, number 4, sulfur and oxygen. Do the substances involve organic compounds or non-polar covalent bond or noble gases? So, wala. So, punta tayo sa no. Do the substances involve metals or ionic compounds? May metal ba dito or ionic compound? Wala. Do the substances involve hydrogen bonded with either fluorine, oxygen, or nitrogen? Wala. So, dito siya sa no. Dito siya sa dipole-dipole interactions. Number 5, NH3 or ammonia. Do the substances involve organic compounds or non-polar covalent bond or noble gases? No. Do the substances involve metals or ionic compound? Parehong non-metal ang nitrogen at hydrogen, so no. Do the substances involve hydrogen bonded with either fluorine, oxygen, or nitrogen? Yes. So this is hydrogen bond. So with this graph, we can identify the type of intermolecular force present with the involved substances. So that's it for module number 3. For the next module, we will discuss the importance of these intermolecular forces of attraction.